Okay, now I'll explain question 6a, which asks how the coefficient in linear regression are estimated using either the closed form solution, also called the normal equation, or using gradient descent. Let me begin with the basic model. Y equal to xp, where x represent y cap equal to xp, where x represent the input matrix containing features. B beta is the vector coefficient of the vector of coefficient. Y predicted is the predicted output. This and this. The goal of training linear regression is to choose beta such that the mean square error is minimized. On my slide, the cost function is given as this. Summation of y predicted minus y actual whole square divided by 2m. Minimizing this cost gives us the best fitting line. So moving on to closed form solution, this normal equation gives the directly coefficient directly without iteration. We are given with the equation of beta here. We first compute the matrix x transpose x, and then compute the inverse matrix of the same thing, and then multiply it by x transpose y. This directly gives us the beta. We follow all these 3 steps. So advantage of closed form solution are exact solution, no learning rate needed, best for small or medium small size data set. Disadvantages are requires metric conversion, slow if data set is very large, maybe for number of rows greater than 10,000 features. It has a high memory usage. Okay, from slide we can see the matrix size is equal to 1, 2, 1, 3 has features, and y is 2, 3, 6. If we calculate the beta, we'll get the slope, and we'll get it is 1.9, and an intercept is negative 0.33. This creates a line that best fits the data points. Now moving on to the gradient descent method. Gradient descent is an iterative optimization algorithm, especially for large data sets. The idea is start with random coefficients, compute the gradient of the cost, and update beta repeatedly until the cost stops decreasing. Steps shown in the slides are: first, we can initialize coefficients beta equal to 0, some small random value. Then compute the predictions y cap equal to x into beta, compute gradient, and then update the coefficients. You can see it over here. Calculate, compute predictions, compute the gradient, and then update the coefficients. Okay, we repeat it until convergence. So, let's see the comparison table for this. Speed is speed for closed form and gradient descent. Speed is fast for small n and good for large n. Exactness, in closed form we get exact, and gradient descent we get approximate. In closed form we requires metric inverse, it is required, but in gradient descent it's not the case. It works well with features that are less than 10k, and gradient descent can work with millions of features. Memory usage for closed form is high, for gradient descent it's low. So in summary, the closed form method gives us an exact mathematical solution, while gradient descent gives us an approximate but scalable solution that works for very large data sets. So moving on to the next question, explain logistic regression and use the logistic function to calculate the probability of a class for a given input. So let me start with the concept. What is logistic regression? Logistic regression is a classification algorithm used when output is binary. Examples: yes, no, 0, 1, fraud, no fraud, BNS, not BNS. So logistic regression predicts probability of y given at x, this one. And how logistic regression works: first step is to compute the linear score. It first computes the linear score, which is given as this, and then apply the sigmoid function, and the equation for it is given as this. So the final prediction probability comes out to be after setting a threshold, we find the value of logistic regression. We get probability. If the probability is greater than 0.5, it classified as 1, otherwise 0. So this slide provides a model's coefficient for predicting whether a case falls under BNS 80 dowry death. So features are intercept beta naught is minus 0.20, beta 1 is 1.5 or 15, I guess. Beta 2 is negative 0.3, and beta 0 is 21, beta 3. So we first calculate the linear score as this and find it out as z equal to 1.0, and then apply the logistic regression function, and we'll find it out as 0.731. So the final regression is 0.731. It is a BNS 80 section, which is dowry death. So let's see the concept table. Logistic regression is binary classification model. Linear score weighted sum of inputs. Sigmoid function converts z into probability. Output probability of class 1. So logistic regression converts a linear combination of features into a probability using the sigmoid function, and this probability helps us classify cases such as predicting BNS 80 or predicting student passing or failing. So if you find this video informative, please do like, share, and subscribe. Have a great day.